Welcome to the favorite spot where learning's never tough.
You are welcome to Excellent Touch Tutorials, and of course, this is Sir Isaac. In my previous video, I discussed on the types of physical quantities and explained the fundamental quantities. In case you have not watched it, please use the link provided to access it and to watch it. In this video, I'll be sharing on the derived quantities in continuation of the last video on measurement of physical quantities. Now let's get started. What is derived quantity? Derived quantities are quantities that are obtained from the simple combination of fundamental quantities. So it means derived quantities are those quantities that depend on fundamental quantities. They are defined in terms of fundamental quantities. So you need fundamental quantities in order for you to have derived quantities. Similarly, derived units are units of derived quantities. So they are obtained by the simple combination of the units of fundamental quantities. Units of fundamental quantity makes up derived units, just the same way fundamental quantities makes up derived quantities. Now here is a table showing derived quantities, their symbols, their derivation of formula, and then their SI units. First on the list we have area. So area is a derived quantity and the symbol is capital letter A. The formula is length times breadth and the unit is meter squared. Number 2 is volume. Has a symbol capital letter V and the formula of volume or the derivation of volume is area times height or length times breadth times height. And the SI unit is meter cube or meter raised to the power of 3. Number 3 is speed or velocity. And the symbol is V or U as the case may be. And the formula is distance all over time or displacement all over time. And the SI unit is meters per second. ms raised to the power minus 1 is read meters per second. Good. Number 4 we have acceleration and the symbol is small letter a. The formula of the derivation for acceleration is velocity all over time and the SI unit for acceleration is meter per second squared. Meter per second squared. Number 5 is force and the symbol for force is capital letter F and the formula for force is mass times acceleration. Mass times acceleration. And the SI unit for force is Newton. But in terms of the fundamental quantities is kilogram meters per second squared. Number 6 is density and the symbol for density is rho and the formula for density is mass all over volume and density is measured in kilogram per meter cube. Kilogram per meter cube. Number 7 is work or moment. Work done or moment of a force. Work has the symbol W while moment have the symbol M, but they have the same formula which is force times perpendicular distance. And the SI unit of force or moment is joules or Newton meter or kilogram meter squared per second squared. Number 8 is pressure and the symbol for pressure is P. The formula for pressure is force all over area and the SI unit for pressure is the Pascal. 1 Pascal is the same thing as 1 Newton per meter squared or kilogram per meter per second squared. Number 9 is impulse and the symbol for impulse is capital letter I and the formula for impulse is force times time and the SI unit for impulse is Newton second or kilogram meter per second. Number 10 is momentum and the symbol for momentum is capital letter M. The formula for momentum is mass times velocity and the unit of momentum is kilogram, is Newton second as well or kilogram meter per second. Number 11 is energy and the symbol for energy is E. The formula for energy is half mv squared or have mass times velocity raised to the power of 2, or mass times acceleration times height. The SI unit of energy is joules. 1 joule equals 1 Newton meter, or kilogram meter squared per second squared. And number 12, power. Power has the symbol P and has the derivation of the formula energy all over time, or work done all over time. And the SI unit of power is the watts. And 1 watt equals 1 kilogram meter squared per second cube. Now at this point, having looked at fundamental quantities and derived quantities and their units, I'd like us to look at the differences between fundamental quantities and fundamental units. First, fundamental quantities are generally accepted, while derived quantities are not generally accepted, but they are just accepted. There is a difference. Number 2, fundamental quantities can stand alone, but derived quantities cannot stand alone. They have to depend on fundamental quantities. Number 3, fundamental quantities have direct calculations, but derived quantities have derived calculations. Number 4, fundamental quantities are based on international system, while derived quantities are formulated from international system. Number 5, examples of fundamental quantities are mass, length, time, temperature, and so on, while examples of derived quantities are area, force, pressure, density, and so on. Now it's quiz time. Number 1, what are derived quantities? Define derived quantities. Explain derived quantities. Number 2, which of the following physical quantities are derived? First, we have area. Second, we have thrust. Third, we have pressure. And fourth, we have mass. So, option A, is it first, second, third, and fourth? B, is it first, second, and third only? C, is it first, second, and fourth only? D, is it first and third only? So choose the correct option of the ones that makes up derived quantities. Number 3, which of the following unit is derived? A, kilogram. B, meters. C, Kelvin. D, Newton. Number 4, mention 2 differences between fundamental quantities and derived quantities. Please do leave your answer in the comments, and this is your assignment. I hope you had a great learning experience. Show your support by liking, subscribing, and commenting. In my next video, I'll be sharing with you on the concept of the SI unit system. Thank you for watching.